Today we are starting our section dealing with the Pythagorean theorem. You guys should have been already introduced to this at some point in your life. But what I want you to do right now is I want you just to follow along so you have a better understanding of how the Pythagorean theorem works. The very first thing that I would like you to do is carefully draw a line segment from B to C. I'm doing it in red. Then A to C, I'm going to be doing in blue. And last but not least, from A to B, I'm doing in green. After you do that, you'll notice that we have created what's called a right triangle. All right? We have a right triangle. Now, what we're about to do only works with right triangles and only right triangles. What do you notice about the distance between C and B, or B to C? What's that side? 3. So what I want you to do is I want you to go 3 units down, and 3 units over, and 3 units back up. And what I would like you to do is color that in red, or whichever color you choose to use. Right there, just color that in, just like that. All right, the next thing that I would like you to do is look at the distance between A and C and count. 1, 2, 3, 4. So what I want you to do is I want you to draw a square that is a 4 by 4 square. And then color that square in. All right, the next thing we're going to look at is we're going to look at the distance from A to B. Now, I want you guys to imagine if I asked you right now, what's the slope of A, B? When I say slope, I mean rise over run. Think about the rise over the run. How much does that go down? 4. And it goes over 3. So on your paper, somewhere over here to the right, if you have a little bit of room, just say slope of segment AB. It goes down 4 and over 3. That's the slope of AB. I want you to understand a perpendicular, by the way, this is the symbol for perpendicular. A perpendicular, we're going to write perpendicular slope without having to write the word perpendicular because that upside down T means perpendicular. The perpendicular slope to a negative 4 over 3 would be a 3 over a 4. That would be the perpendicular slope. And what do perpendicular slopes always form? They always form 90-degree angles. So you're like, what are you talking about? Let me explain. We're going to take this 3 over 4 slope and watch. Go right over here. And from point A, I'm literally going to go up 3 and over 4. And I'm going to put a point. And from point B, I'm going to go up 3 units. And over how many units? 4 units. I'm going to put a point. So one point is literally at a 7, 3. So you could write 7, 3 in case you're confused. The other point is at a 4, 7. So we'll put a 4 and a 7 right here. And then, and only then, after you plot those points, then take your ruler and connect dots. And once you've connected those dots, then and only then would you please shade this square in. Ooh, it is a right triangle. You are right. That's big. Now, whenever you go to a store, all right, like say Lowe's or Home Depot, and you wanted to get some carpet, all right, what do they sell the carpet typically in? Feet? Not feet, but square feet, or square meters, or square yards, okay? So each of these little units right here is a square unit. So even, you know, a kid in elementary school, if I said, hey, what's the area of this square right here, what would they say the area is equal to? 9. So right now I want you to write 9. I want you to write units squared. Now I realize you can't write it in the box, but you could write it outside the box and put this area of this square is 9 units squared. Okay, so 9 units squared. You could use your pencil if you wanted to make it nice and dark so you can see it. Okay. Now, over here in this square, each side was a 4, right? Each side was a 4. So how many square units do we have in this box? 16. So write down 16 units squared. All right. Now, right here, I want you guys to understand, in this right triangle, this typically is referred to as side A, and that side is equal to a 3. This side right here is typically referred to as side B, and that side was equal to a 4. Okay? Now, understand, it's pretty easy to count. 1, 2, 3, 4. 1, 2, 3, 4. We can't really count the distance of this side. Now, I know you guys probably already know the distance to the side, but you can't really tell the distance from here to here. Why? Because it's not going horizontally, and it's not going vertically. But the Pythagorean theorem, you guys cough way too much. It's ridiculous. Right? When I say a squared plus b squared equals c squared, I need you guys to understand what that actually means. It means the area of the little square plus the area of the medium square will always equal the area of the largest square. So what was the area of the little square? 9. What was the area of the medium square? 16. And 9 plus 16 gets us to a 25, which means without having to do a whole bunch of complicated math, this side right here, when you square it, will equal the sum of these two squares. So the area of this square plus the area of this square will always equal the area of this square. Okay? So I'm going to put 25 units squared. Because I want you guys to understand, I don't want you just to know the math. I want you guys to see the picture behind the math. All right? So over here, yes, 3 squared plus 4 squared equals 5 squared. Okay? 3 squared plus 4 squared equals 5 squared. That's the Pythagorean theorem in work, not just in math. Okay? So, the area of this square plus the area of this square equals the area of this square. Okay? Now, let's go and flip over on the back. Does this only work in the most common triangle known to humanity, the 3, 4, 5 triangle? No, it works in not just one right triangle, it works in all of them. So right now, go to the back. We're going to the back right here. So right here, if you look at this theorem right here, you could write that down in your journal, but now you have a picture that goes with it. So I'm going to go right over here. Okay, I'm going to zoom out just a little bit. There we go. Now we should be able to do this. So first thing I want you to do is I want you to make a red segment right here. I want you to make a green segment right. Oh, not green segment. No, you don't have to make it that color. You can make it your own colors. But I want them to be 3 distinct colors. All right, so go ahead and make your next right triangle, because I want you guys to see it not just in one right triangle, but at least 2 right triangles. So you see the pattern. It still works. All right, now, as we look at this, what is the distance from B to C? What's that distance? So what I want you to do is I want you to make a square that is a 6 by 6. 6 by 6. So you're going up just like that. You're making a 6 by 6. And then you are all the way up. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. What's the distance from the old A to C? 1, 2, 3, 4, 5, 6, 7, 8. We're going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. All the way. Wow. Like somebody knew what they were doing when they made this little lab. Must be. Oh, look at that. Could be. Whoever it was, he knew what he was doing. Or she, but I already know who built it. All right. Okay, for the last square that we're going to build, I want you to look at the slope, everybody. Look at the slope B to A. How much does it go down and how much does it go over? So it goes down 8 over 6. We're not going to reduce it this time. We're not going to reduce it. So I want, what would be the perpendicular slope?
6 over 8.
Nope. 6 over 8. Remember, perpendicular slopes are what's called negative reciprocals. So this is a concept that you need to know, not just today, you need it to know forever. You need to know that negative reciprocal slopes are perpendicular. So right now, I want you to understand, what is my rise? My new rise is going to be a 6. My new run is going to be 8. So how do I apply that? Here's how I apply it. Okay? I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go down 1, 2, 3, 4, 5, 6. Right there. That's where I'm at negative 11, negative 1. That is where you put an order pair. Over 8, down 6. On this one, we also have to go over 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4, 5, 6, right here. So at negative 5, negative 9, negative 5, negative 9, put a point, and then connect your dots from B to that point and from A to that point. So eventually, you can make your final and last beautiful square.
So from A, you're going to go down 6 over 8 also.
No, yes, down 6 and over to the left 8. If you're wondering what I just did there, I'll try to do a better job of helping you understand it. So right now, I want you to understand that from here, right here, okay? From here to here, this distance right here is 1, 2, 3, 4, 5, 6. This distance is a 6. This distance all the way across is an 8. Okay, so there you go, up 6 over 8. That's your slope to make it perpendicular. So now you have right angles everywhere. Okay. All right, in summation, if we take this side, which this side is equal to a 6, and we take this side, which is equal to an 8, 6 times 6 is 36. So that's 36 units squared. 8 times 8 is 64. So there are 64 units squared. If you add 36 and 64 together, that's going to yield you 100 perfect square units, also known as units squared. And what is the square root of 100? That means you have to have a 10 right here. Now, in your journal right now, what I would like you to do is I would like you guys to list some common Pythagorean triples. By the way, the triples that we did today were a 3, 4, 5, and then I doubled it. And I doubled it to make it a 6, an 8, and a 10. The next 3 most common Pythagorean triples, the next 3 are a 5, 12, 13. The next one is an 8, a 15, and a 17. And the last but not least one is a 5, 24, and not 5. That was another. 7, 24, 7, 24, 25. Now you can double these, and you'll still get a Pythagorean triple. All right, if you double this one, that becomes a what? A 16, a 30, and a 34. You double this one, that becomes a 14, a 48, and a 50. Are these the only Pythagorean triples known? No, there's lots of them that are out there. Pythagorean, put these in your journal right now before you leave. These are the most common Pythagorean triples. Now, what is a Pythagorean triple? That's where a squared plus b squared equals c squared, and they're all perfect little integers, which means there's no decimals involved. These you need to know by heart. All right? You need to know the 3, 4, 5, 5, 12, 13, 8, 15, 17, and the 7, 24, 25.